Hey guys, very good evening everyone and welcome to another session by 360DigiTMG. We have been discussing about the domain analytics series, and in this we have been discussing about cyber security analytics. Since past few days we have been discussing a lot about various, models and clustering, KN and all these things we have discussed. We have discussed about ED and all those stuff we have discussed. Today we will be discussing about linear regression and how we are going to use the linear regression for our use case. And I have made I have created this session for you guys, and the objective of this was to deploy a data analysis for the analysis of cybersecurity data. By the end of this session, we'll be looking into it as well, and I have done this on my Jupyter notebook. I have used my XGBoost and linear regression algorithms to evaluate the learning. Now, coming back to the slide. So what is the linear regression? Let us try to understand that first, even before venturing into, other things. Its usage and all these things, but what actually is a linear regression? So linear regression, guys, is a machine learning algorithm based on supervised learning. Linear regression, you can say in other words, it's a kind of algorithm that provides a linear relationship between an independent variable and a dependent variable. To do what? To predict the outcome of the future event. This linear regression is also a statistical method used in data science and machine learning for predictive analytics. Predictive analytics. Now, the independent variable which we were talking about. Now that independent variable is also the predictor or explanatory variable that remains unchanged due to the change in other variables. However, the dependent variable changes with fluctuations in the independent variable. The regression model predicts the value of the dependent variable, which is the response of your what? Response or outcome variable. That is the response or the outcome variable being analyzed or studied. Thus, you can say that, linear regression is a supervised learning algorithm. This is what it is written in. Supervised learning algorithm that simulates a mathematical relationship between what? Between variables and make predictions for continuous or numerical variables such as your sales, salary, age, product, cyber attacks. When we talk about, whether something is malicious or not, all these things we can do with our linear regression. So linear regression, as I told you, is a machine learning algorithm based on supervised learning. It performs regression tasks. Regression models are target prediction value based on the independent variable. It is mostly used for finding out the relationship between the variables and the forecasting. If you receive the mail and you want to know whether this is a malicious mail or not, you can choose it. By using this, you can perform this analysis. Different regression models differ based on the kind of relationship between dependent and independent variables they are considering and the number of independent variables getting used. Now, your linear regression is also being used to predict the value of a variable based on the value of another variable, guys. The variable which you want to predict, that is called as a what? Dependent variable. The variable you are using to predict the other variable's value is called as a what? Independent variable. Okay. even before we come to this, okay, let me give you guys a chart. Let me quickly draw something for you. Okay. Okay, this is your y-axis, this is your x-axis. This is a 9, and these are some. These what you are seeing, these are your data points. This what you are seeing. This is your what? This is your line of regression. This you are seeing over here, this is your dependent variable. And this what you are seeing, this is your independent variable. Now, when we see this figure, your x-axis is your dependent variable. Sorry, yeah, x-axis is your dependent variable. Y-axis is your independent variable. No, just a moment, my bad. This is going to be your x and this is going to be your y. X-axis is your independent variable and y-axis is your dependent variable. Line of regression, this line which you are seeing over here, line of regression. This is the best fit line for this model, all this data you are seeing. Now here a line that is plotted for the given data points that suitably fit all the issues. Hence, this is called as these are all the issues which you are seeing, all the issues, data points. And this line which is being drawn, that is suitably fitting all the issues. Hence, it is also called as the best fit line. The goal of the linear regression algorithm is to what, guys? Is to find this best fit line which is seen in this figure. This is our goal. Okay. Now here we have some applications of your linear regression. That is predicting, say, crop yields based on the amount of rainfall. Yield is dependent variable, while the amount of rainfall, by the figure which I drew before, you can make out what I'm talking about, independent and dependent variable. Marks scored by student based on number of hours studied. Here, marks scored is what? Your dependent variable. Number of hours studied is independent. Predicting the salary of a person based on the years of experience, all these things is where you can use your linear regression, simple linear regression, talking about basically. Then what are the benefits of, we are talking about your applications of linear regression, then what are the benefits of your linear regression? Linear regression, guys, is as you know that it is a very popular statistical use tool that is being used in the data science because of various benefits which it is offering. As in, first one is easy implementation. Easy implementation. That is the first. When I say easy implementation, it means that the linear regression model is computationally simple to implement as it does not demand a lot of engineering overhead. Okay. Neither before the model launch nor during its maintenance. Second thing, interpretability. What happens is, unlike your other deep learning models as your neural network, linear regression, guys, is relatively very straightforward. As a result, this algorithm stands ahead of black box models that fall short in justifying which input variable causes the output variable to change. Third thing, scalability. Scalability, guys, just a moment here. Sorry for that. Yeah, we were talking about scalability. Linear regression, guys, is not computationally heavy, and therefore it fits well in cases where scaling is essential. For example, the model can scale well, regarding increased data volume. That is a big data. Even we are having a big data, even if you are dealing with a big data, scalability is not an issue when we talk about your linear regression. Again, another point, it is optimal for online settings. The ease of computation of these algorithms allows them to be used in online settings. Now, the model can be trained and retained with each new example to generate what predictions and in real time. Unlike the neural network or support vector machine that are computationally heavy and they require plenty of computing resources and substantial waiting time to retain, or sorry, not retain, I would rather say retrain on a new data set. All these factors make such computer intensive models expensive and unsuitable for your real-time application. Okay, this is one thing. Online settings. It is very optimal for online settings. Okay. Let me quickly give you guys an example. Suppose we are having a data set. Let me draw this. This is my RAM capacity, and this is your cost. This is 2 GB. This is your 4 GB. Say 8 GB. Say 16 GB. Say this is your, $12. Say this is your $16. Say this is your $28. Say this is your $62. Now, let us consider we have a data set that covers our RAM sizes and the corresponding cost. In this case, the data set over here is comprising two distinct features, that is your memory and cost. The more RAM, the more purchase cost of your RAM is going to be. If we plot RAM on the x-axis in this way, this is your capacity, which is your RAM, and this is your cost. say these are the various numbers, right? These are the various numbers. These are the various numbers, and you are getting a best fit line like this. If you plot a ramp on the x-axis and its cost on the y-axis, a line from the lower left corner over here of the graph to the upper right corner represents the relationship between x and y. This is representing the relationship between what? Between x and y. Okay. On plotting these data points on a scatter plot, we will get something like this. Again, there will be some lines drawn like this, but you can make an idea. The memory to cost ratio may vary according to different manufacturers and RAM version. Intel will cost you more, and say AMD Radeon, Ryzen will be costing you more or less compared to your Intel. All these things are there. But the data trend shows a pattern. The data on the bottom left shows cheaper RAM. This side, right? This is showing us cheaper RAM with a smaller memory. Obviously, this is going to be small memory. And the line continues to the upper right corner of the graph, where the RAMs are of higher capacity. And if it is having a high capacity, it will be having higher cost as well. Okay. So this is one example which I wanted to show you guys. Talking about the types of linear regression. Talking about the types of linear regression. There is simple linear regression. What is this? Simple linear regression, guys, reveals the correlation between a dependent variable and independent variable. Primarily, the regression type describes what? Relationship strength between the given variables. Then we have something called as a multiple linear. Multiple linear regression establishes a relationship between the independent variable and the corresponding dependent variable. Here, the independent variables can be either continuous as well as your categorical. This regression type helps foresee trends, right? When we talk about multiple linear, it helps us to foresee what? Trends. And it also helps us to determine the future values and predict the impact of the changes. Then we have something called as a logistic regression. What is this? Logistic regression, guys, is also referred to as logic model. This is applicable in cases when there is no dependent variable and more independent variable. The fundamental between, the fundamental difference between, you can say, multiple and logistic regression is that the target variable in the logistic approach is discrete or binary. Implementing the fact that the dependent variable is finite or categorical. That is either P or Q, that is a binary regression, or a range of limited option, that is PQRS, all these kind of things are there. The variable value is limited to just two possible outcomes in linear regression. However, logistic regression does what? Addresses this issue, as it can return a probability score that shows the chances of any particular event. We have ordinal. We have ordinal regression also. Ordinal regression involves around one dependent dichotomous variable and one independent variable. which can either be what? Ordinal or nominal. It facilitates the interaction between your dependent variables with multiple ordered variables, with one or maybe more than one independent variable. What happens over here is that for a dependent variable, say with m category, m minus 1 will be your equation which will be created, m minus 1 for m number of categories. Now each equation has a different intercept, but the same slope coefficient for your predictor variable. Thus, what ordinal regression does is it creates multiple prediction equations for various categories in machine learning. Ordinal regression refers to ranking learning or your ranking analysis computed using a generalized linear model, also called as a GL. Then we have something called as a multinomial regression model. Multinomial. Multinomial logistics, guys, it's performed when the dependent variable is nominal with more than two levels. It specifies the relationship between one independent nominal variable and one or more continuous level independent variables. Here, the nominal variable refers to variable with no intrinsic order. Okay. If I were to give an example for your multinomial regression, then multinomial regression can be used to model the program choices made by, say, a school student. The program choices, just a moment, guys. Guys, give me a moment. I need to switch my Wi-Fi. Mahinder Reddy, why have you unmuted yourself, Mahinder Reddy? Yeah, thank you, Mahinder. Let us maintain the decorum of the session. Okay, so we have been discussing about what? We have been discussing about a multinomial logistic regression. Now, this multinomial logistic regression is performed, as I told you, is performed when your dependent variable is nominal with more than two levels. It specifies the relationship between one dependent nominal variable and one or more continuous level independent variable. Here, the nominal variable refers to a variable with no intrinsic ordering. And I was giving you example that multinomial regression can be used to model the program choices, as in made by the school student. Let us assume that. The program choices in this case refer to a vocational program, or say it may be your sports program, or it may be your academic program. Okay. The choice of type of program can be predicted by considering a the choice of the program, choice of the type of the program can be, predicted by considering a variety of attributes. We all know that, such as how well the students can read and write on the subjects, given gender, and awards received by them, all these things. In the short, if I were to say that, today Linear regression models are widely used by data scientists across industries to make a variety of observations. Why? Because these models help evaluate trends, make sales estimates, analyze pricing elasticity, and assess the risk to the company. Experts can adopt specific best practices to ensure the smooth implementation and functioning of linear regression models. Talking about your use of linear regression in cybersecurity. So here we can say that linear regression can be used to predict network security outcomes based on the deployment of certain defense and the security tools. Decision theory provides a normative framework for representing and reasoning about the decision problems and the uncertainty. This could be one possible use of your linear regression when we talk about cyber security things. Okay. Now here guys, what I have done, I have taken a cyber security data set and I have deployed data analysis for the analysis of that same data set. I have also performed anomaly detection using XGBoost and linear regression algorithm. And then I've tried to evaluate its learning profile. Now this is an open source data set, right, which I have, taken from Australia Center for Cyber Security, which was published in 2015, but it is the one of the latest data set which I was having. So here, what actually I've done is I have started with loading the required libraries. I've imported NumPy, SNP, Pandas as PD for data processing and all these things. Then I have loaded the data set over here. After loading the data set, I have said training underscore set dot head. I have saved this information into a variable called as training underscore set. And if I say dot head, it is going to give me the top 5 values, right? And then I went into the data observation. And how I'm doing that, I'm just saying that data set name, data frame name, and dot info. It is giving me all the information pertaining to each and every column it is having. It is having 45 columns, and for all those 45 columns, it is giving me the information. Again, when I say training dot head, then it is giving me top 5. Now I'm trying to find out my categorical variable, and I am also trying to see my numerical variable. To find my categorical variables, what I'm doing over here is I'm saying mask is equal to training underscore set dot data type is equal to np dot object, and I'm saying print training underscore set dot loc. I have initialized the indexes over here. Dot head I have given. List underscore cat is the variable which I'm creating, and this information over here, which is being extracted by initializing this parameter, I have stored in the list underscore cat, and this is what I am getting. Total service state attack category, all these are there, and this information is what I get. When we are talking about your categorical variable, now when we deal with our numerical variables, here I have again used all these parameters and I have stored that into a variable called as mask. Again, all these things I am doing. Here when I'm saying training underscore set dot loc mask dot describe, these all variables are being generated, which are your numerical values. All these things. Here I have to give the index location and which columns I had to save or not take, everything I have done. This is how I have created my numerical variables. see, these are the columns and all the columns which are existing, which is shown over here. And this way it will be shown. 8 rows and 44 columns, 41 columns. Now, when I have the whole all my numerical variables and categorical variables, I am trying to do the evaluation on that training data set, which I have created. And here, this is what I'm doing. I'm trying to check whether the positive label match the attack categories or whether the attack categories match my labeled data. And for that, I am initializing all these parameters. I'm saying print all training underscore set dot label is equal to 1 and training underscore set dot attack cat not equal to normal. All these things I have done. So what will eventually happen over here? That it will return true. These conditions will return true if all the elements of the iterable are considered as true value. And here we are getting true, I guess. Yeah, here we are getting true. And then we are trying to find what? We are trying to find the number of occurrences for each category. See, we are having numerous categories. I guess we are having 41 categories over here. We also need to know that for each category, what is the number of attacks that happened? We need to. And this is what I have calculated. Training underscore set dot attack dot cat underscore cat dot value underscore count. We know when we say value underscore count, it is going to give us what? It is going to give us the total value of what? The number of attacks that happened in that category, which is existing in my training underscore set data frame. And this is what I am getting over. For generic, I am getting this number of values and exploits for the videos. We all discuss these kind of attacks in the first day of our domain analytics, right? We discuss all these. Then what I'm doing over here, I'm trying to find out that which protocol and service appears in the positively labeled entry. All these, sorry, all these are your what? Various possible labeled entities, positive label. This is what I'm trying to find. I'm doing the labeling over here. Label is equal to 1. Again, I'm using my value count for finding out the service. For finding out the counts of the service appears, I'm using my value count to find, appears for my protocol. And in this way, I am getting all my data. Now, when we observe this point over here I am getting this thing. Here I am getting proto length 129 b type integer value. After all these things are done, you also need to check that in the negatively labeled one, is there anything existing or not, right? Here what we are checking? We are checking your positively labeled entry. But here what we are doing? We are checking our negatively labeled entry. So again, the same thing, value counts and for your service and your prototype, I'm trying to find out a negative count. Previously, if you see, it was label is equal to 1, but here I am giving label is equal to 0. And after using this, I'm getting whether the negatively labeled values are existing or not. So here I am getting proto D type 164. Here I am getting length 129. Here I am not getting my data. Then I have started doing my data cleansing. Again, I have initialized two variables. For variable y, I am giving the values which are in my training underscore set data frame dot label. For the x variable, I am saying training underscore set dot drop columns. I am trying to drop these two columns. I don't think that it is holding much value for me. ID, attack underscore category and label. Mask is equal to x dot d types is equal to np dot object. List underscore category. All these parameters I have initialized. After running this, when you run this, you will be getting proto service state. These columns have been dropped. Then I have started creating your dummies for x variable. I have said pd dot get underscore dummies, and here I have initialized the parameters. When I say x is equal to head, see all the dummy variables over here have been generated. I have generated all the dummy variables over here. See, for each column, dummy variable has been generated. If I say y dot head, it is going to give me top 5 values. We know that. Now, as I told you that we will be using your XGBoost and linear regression, right? So here I have started my machine learning analysis. Just a minute. So here I have imported scalar. I have imported train underscore test underscore split from scalar.model underscore selection. I have imported max process. Here I have initialized the parameters. I have imported XG2 and I have imported classification underscore report and all these things from epsilon.max. Here I have created a function called as forerunner is equal to maximum depth I want to take as 10. Objective should be multi is to softmax, that is error value evaluation for multi-class training. Number of classes I wanted to take 2, and this is yet another parameter n underscore GPU is equal to 4. This is what I've given. Here again I have given this particular variable called as xg underscore cls is equal to xgb dot xgb classifier, and I will initialize this thing over here. This is what I did. After running this, this is what it is as an xgb classifier. Base underscore score is equal to 0.5, booster is equal to gbc, pole sample, that is column sample by level is equal to 1. All these things are given. Now, if you try to do the prediction, this is what you are getting. I have tried to do the prediction over here. Initialize the parameter using these variables which I have created. Precision for this particular row, I am getting 0.97, recall 0.98, F1 is for 0.98, support 741, accuracy is 0.98 I am getting, macro average and repeating. All these things I have calculated. This is using your experience. Yeah, Sangini. Yeah, Sangini. Machine learning. Is it clear now, Sangini Sharma? I have done this on Jupyter notebook. I am using Jupyter notebook over here. Sangini, is it clear? Okay, so I'm assuming that is very clear. Now here I have created AUPRC store. That is nothing but I'm trying to see that whether your cover is the average cover of a split which uses the feature. Where coverage is defined as the number of samples affected. See, we are trying to see how many samples are getting affected by your cyber attack, or what is the intensity of the attack which you are having. Here again, by using XCB boost, I am saying XCB dot plot underscore important. XGB underscore classification, classify importance underscore type is equal to cover. And when I'm trying to draw a plot here, this is what I have done. What it is showing? This is showing us the average coverage of the split which use the feature when coverage is defined as the number of samples that is affected by the split. Getting the point? When we talk about the plot importance and features with type 2, weight is the number of times a feature appears in it. We all know that. And this is what we are trying to see over here by, plotting this plot. See. Here, what I have done is I have taken XGB.plot underscore importance. I have taken this particular XGB underscore classifier importance underscore type is equal to weight. By plotting this, we are trying to see the feature importance. What is the importance of each feature? See the features of SY, SVP underscore SRV underscore SRV. So here we are trying to see the feature importance from the descending order. It is being displayed. As its code is given on this particular slide axis. Now here what we are trying to do, we are trying to plot the importance of features using type again. Using your type again. This is what we are doing. Again, यहाँ पे importance type what I have given is game. Here I have given what? I have given this. We have to use various parameters. See here I have given cover. So different type of inferences you can see which are being created. Feature importance is there, there here we have used weight, coverage we have used. All these things I have done. Now if you plot a single tree, this is a plot and the first decision tree in the model showing the features and the feature values for each split as we do what? As we proceed with the output leaf node. All the detailed information, all the detailed information. Yeah. And then we applied, all other things. I will be showing you in the coming class. Okay. So guys, this is what I needed to discuss about today pertaining to our, analysis of your cybersecurity data. This was also our cybersecurity data which we loaded, and this is what the analysis we have using various, important types. That is, one is your coverage, one is your weight, and this is the analysis which we needed to do, and we have done that. So this we can make, useful insights. We can give them to the management of the company or the person. This is how you do the thing. Again, the codes and the data set will be shared to you guys. Maybe tomorrow I'll be sharing all these things with you people. Guys, we are also doing a free Python session, and I hope you people have joined the group. If you have joined the group, then it has been shared over there. The details, the link, and all these things. Again, it is a Python session, and it is being the taken by Bharimi, a very renowned personality when we talk about the data sciences, having connections everywhere. Every analytical head in most of the organization knows him. He is having an experience of around 16 years, and he is, one of the chief data scientists working for various companies as well. So you might not want to miss those sessions. We have the links in the Telegram group, people, so you can join that. It is a free session. You don't need to pay for that. And yeah, join it. I would request, and you'll be gaining a lot of experience from that. Okay. So guys, this is where I'm going to stop the session for today. Thank you so much for joining, guys. Have a wonderful evening, everyone. And tomorrow we will be meeting again. Thank you so much, guys. Thank you for joining.